Tutorial sheet 1, question 4. We're given this function x of t is equal to 2 impulse functions, delta of t plus 3 minus 2 delta of t minus 3. And we're asked to first of all plot simply x of t first of all. So these are just two impulse responses. However, at what time do they occur? Because there are two time shifts. So for this first one, again, we're looking for when the argument is equal to 0. So t plus 3 is equal to 0. That occurs when t is minus 3. For this function, again, t minus 3 has got to be equal to 0. So that is occurring at time 3. So for these functions, the delta function is occurring at t is minus 3. For this one, you have t plus 3. So that when we plot the graph of that, so we're going to be interested in minus 3 and 3, and we're going to be interested in amplitudes. Well, of course, an impulse has an area that we nominally give it an amplitude of 1 and minus 2. So try and draw this to scale. So we're going to be looking at that. So as we always do with an impulse, we draw that with an arrow. So that's a positive arrow. And at this time t equals 3, we have a negative arrow at minus 2. So that's how we sort out part 1, just drawing x of t. Then we need to look at part 2, which is the integral from minus infinity to t of x of tau d tau. So we're integrating this graph. So again, I'm going to draw my graph here. So we're plotting x of tau d tau. So what are we actually going to get? So if I start integrating this function, well, if I integrate before t is minus 3, I'm obviously going to get nothing. Now at this point t is equal to 3, we've got the impulse function. Now the impulse function has an area of 1. So at t is minus 3, we're going to get an increase to 1. That's not going to change until you get to t equals 3. And then we're going to have an area which has got minus 2. So that's going to come down at t is equal to 3 down to minus 1, because we're subtracting 1 minus 2. This gives us minus 1. And then that graph goes off to infinity.